In this clip, I will show you how to use authentication for EIGRP. Like we just discussed, we'll first shut off securing the control plane. On a Layer 3 device, this means securing the dynamic routing protocols, and I will start off by securing EIGRP. To do that, I will add an MD5 hash of a passcode. Each EIGRP neighbor will send this hash to each other, and they will expect it from each neighbor. This way, an attacker isn't able to place a device between the two routers and try to form an unauthorized EIGRP neighborship and inject malicious routes. For EIGRP, we first do this by creating a key inside of a keychain and then referencing that keychain on each interface that is participating in EIGRP. It is the same configuration for RIP, which we will configure in the next clip. For OSPF and BGP, we won't use a keychain. Rather, for OSPF, we will specify the authentication key right on the interface that is participating in the OSPF process, and BGP, we will configure the key globally in BGP configuration mode. So for this demo, I will first configure EIGRP and add the local networks. Then, I will create a keychain and create a key inside of it. I will go into the interface that will connect to the other routers and reference the keychain and then actually turn on the authentication. So let's jump in and take a look at how to configure this. Here I am in router 1, and the first thing that I want to do is to establish the EIGRP process by entering the command router EIGRP, and I will use the autonomous system number of 100. Then, I will add both of my local networks, the 12.12.12.0/24 network and the 1.1.1.0/24 network. And you may want to think about having more control on which interfaces participate in sending and receiving EIGRP packets. This way, you can be sure to only have the interfaces that you want participating in EIGRP, rather than every interface. To do that, I'll enter the command passive-interface default. And since we want to have interface gigabit Ethernet 01 to participate, I will enter the command no passive interface and then specify gigabit Ethernet 01. Alright, so now I'll exit out of EIGRP configuration mode. Next, I need to create a keychain and then create a key within it. I will create a keychain by using the command key chain, and then I will give it a name of global routing keys. Next, I will create a key within the keychain by typing the command key and a locally significant identifier of 1. Now that we are in the key configuration mode, here is where I'll actually specify the key that I want to use. To do that, I'll enter the command key-string and then use the key of global123 with a capital G. In a production environment, you would want to use a more secure password like we talked about in the Cisco Core Security Concepts course. But for a lab environment, this key will suffice. Now that we have our key configured, I will exit out of key configuration mode and then exit out of keychain configuration mode. The last step that we need to do is to go into each interface that has participated in EIGRP and reference the keyring that we just created, and then to actually enable authentication. I wanted to emphasize that this command is per interface, so if you do not configure it on each interface participating in EIGRP, those interfaces are not as secure. To enable authentication for EIGRP Autonomous System 100, I will enter interface configuration mode by typing in the command interface gigabit Ethernet 01, and then to reference the keychain that we just created, I'll enter the command IP authentication, followed by the word key-chain, and then I will specify EIGRP and the ASN of 100, and finally, the name of the keychain that we created, which again is global routing keys. And then to actually enable authentication, I'll enter the command IP authentication mode, and then specify EIGRP 100, and finally, enter the keyword of MD5. And there's something else that I wanted to show you. If we enter the command show run pipe and specify the section of key, we can see the keychain and the key string itself in plain text. This is also a security risk, since anyone who has access to the router's config can easily see the key string. To create a hash of the key string that will be stored in the config, enter the command service password-encryption. Let me go ahead and back out of interface configuration mode so I can enter this command globally. Again, that command is service password encryption. Now if we do a show run pipe section key, we can see that the key string itself is a hash rather than plain text. So let's jump over to router 2. The first thing that I will do is to enable service password encryption. And then just so you can see that the router will not form an EIGRP neighborship until it has authentication configured, let's debug EIGRP packets. Since we're in global configuration mode, I'm going to type in do and then the command of debug EIGRP packets. Alright, debugging is on, and just like before, I will enable the EIGRP ASN 100 with the command router EIGRP 100. And then make each interface passive by default. And then this time, I will enable both Gigabit Ethernet 01 and 02, since router 2 has both interfaces. And here I'll just use the up arrow, and then change the 1 to a 2. Alright, now I'll add my networks. On this router, it is a 23.23.23.0 network. Here's the debug showing that the hello packet is being sent on the 23.23.23.0 network, the 2.2.2 network, and as soon as I enter the 12.12.12 network, we can see that the router is ignoring the EIGRP packets since authentication is not enabled. If we jump back over to R1 and turn on debugging for EIGRP packets, we can also verify that router 1 is ignoring the packet from R2 since authentication is not enabled. So let's jump back over to R2 and fix that. First, I will turn off debugging by entering the command do undebug all, and then create the keychain and key. Again, the command to create the keychain is key chain followed by the name of global routing keys. Next, I will specify the first key number of 1, and finally configure a key string of global 123 with a capital G. And then I'll exit out of both key and keychain configuration mode. Lastly, I need to enable the keychain on all of the interfaces that I want to use authentication. Just to drive the point home that EIGRP authentication is interface specific, I will configure it on interface Gigabit 01, but not 02. That way, when I enable EIGRP on router 3, the neighborship should form even though router 3 will not be configured for authentication. To enable authentication on Gigabit 01, the commands are IP authentication key-chain, and then specify EIGRP 100, and finally the keychain of global routing keys. Again, the command to actually enable authentication is IP authentication mode EIGRP 100 MD5. And as soon as I enter that, we see that the neighborship is formed. And just to finish off the demo and to show that authentication is not a global configuration, I'm going to jump over to router 3 and configure EIGRP. Again, I'll specify passive interface as a default, and then enable GI01. And then I'll enter both my loopback network, and then the 23.23.23.0 network. And as soon as I enter that, we see that our neighborship is formed without creating a keychain. If I do a show IP route, we can see the routes to the 2.2.2.0 network and the 1.1.1.0 network. Additionally, we can verify that these routes were learned via EIGRP, which is designated by the D. And just to verify that routing is working, let me go ahead and ping 1.1.1.1, source from my 3.3.3 address. And that looks good. Alright, in the next clip, I will show you how to configure authentication between routers that are using RIP version 2.